So in this video we are going to discuss the ninth experiment in module 2. Create an ARFF file and read it in Weka. Explore the purpose of each button under the preprocessor panel after loading ARFF file. And also try to interpret using different ARFF file like weather.arff provided with Weka. So first of all, let us know what is meant by ARFF. See, in this knowledge engineering lab, we are mostly dealing with data sets, and data sets can be stored in different formats, and one of such format is nothing but your ARFF file. Its full form is attribute relation file format, which means that each and every data set will be having different attributes. So, and one of the applications software for data mining is Weka, and Weka will be supporting different types of file formats. So some of the lists are ARFF, ARFF.gz, CSV, comma separated version, next data, like these are all some of the file formats which Weka is supporting. Coming to ARFF, so let us see the structure of ARFF. It mostly consists of two sections. One is the header and other is the data. So the header describes the attribute types, and the data section will be containing a comma that separates between the data. So let us see one example. This is weather data set. Uh, so ARFF file means here we can create our own data set. Here first of all you will be specifying the data set name. The data set name is weather.symbolic and it has to be specified as @relation. Then it becomes the name of the data set. And after writing the name of the data set, the second step is to specify what all attributes are there in your data set. So here @attribute followed by outlook. Outlook is the attribute name and it is having parameters like sunny, outcast and rainy. These are the values that will be there in the outlook column. Similarly for temperature, this is another attribute and its values will be either hot, mild or cold. Another attribute is humidity, which will be taking values like high and normal. The next attribute is windy. It takes values true and false. And the last attribute is play, yes or no. Actually, this is called as the class label or target variable or class variable. So it means that depending upon outlook, temperature, humidity and windy, we can say whether a person can go and play outside or not. So if the temperature, if all these attributes are not uh, in a favorable condition for play, then you will be having an output as no. So once after specifying the data set name followed by the attributes and their class labels, the next thing is you have to specify the data. Data is nothing but the rows that will be there in your data set, and attributes are nothing but the column names. So here data means, see, sunny, comma, hot, comma, high, comma, false. If these are the four parameters, then play is no. That is, if the outlook is very sunny and temperature is high and humidity is also high, naturally no one would prefer to go and play outside even though it is not windy, because it is very sunny and temperature is high. So if it is overcast, temperature is high, humidity is high, and wind is not there, then it is a yes. So these are some of the data values that are being given. So at the rate relation tag means it defines the name of the database. At the rate attribute tag means it defines the attributes, and at the rate data tag means uh, here from this particular place you will be listing the data rows, and each data will be separated by a comma. And one more thing which you have to know is the attribute types. There are different types of attributes: categorical and numeric. In categorical, you have nominal and ordinal. So we will be coming across nominal attributes. So nominal attributes are nothing but only enough information is there to distinguish them. Examples are ID number, eye color, zip codes. These are nominal values, or they can be also simple English values. And ordinal means it gives you information about the order, like grades of a student, street numbers. Interval means the difference between values are meaningful, like your calendar dates, temperature in Celsius or Fahrenheit. And ratios means both difference and ratio between the values will be meaningful. So first of all, I will show you how to create an ARFF file. So that is the first task. Here I am taking a student data set. So actually I am copying this data. What you have to do is you have to uh, type that entire content. I am taking a new document over here called the text document. I am naming it as student, or no need to name it now. We can name it later. And then you have to type this entire data, that is at the rate relation student. Like this, after typing this entire data, click on file and click on save as, and under save as you can type as student um, dot ARFF and click on save. See, you have to save it as student.arff. This you have to remember, and click on okay. Once I have saved it, next you have to open your Weka software. So I'm opening Weka software. So this is how it will open. Now click on Explorer. Once you click on Explorer, this is the uh, screen which you will be seeing. And how to, up till now we have created one data set with the extension .arff. Now we have to load that particular data set. So click on open file, and I have saved it on my desktop. So I will go to the path where I have saved my ARFF file. Click on that file and open. Then if you can see over here, initially it was blank and now you got the details. So here, what are they? SID. SID means student ID, that is it can be a roll number. Name of the student. DM means data mining, web technologies, computer networks, AI, STM, total, and result. So these are the attributes. Here if you can see, relation is student. The number of attributes are 9. Instances are 6. And for each and every attribute, the selected attribute details will be given over here. And this here, if you can see, it is used to visualize your attributes. If I click on visualize all, then you will get a histogram for each and every attribute. So this is the representation. And now once look at this ARFF file, the initial thing is relation student. That is the relation data set, database name is student, and its first attribute is SID. It is numeric. Means always roll numbers will be numeric. So it is numeric. We have to specify the data type also. Next is name. That is name of a student, and it will be taking these values. And next one, data mining. So how much marks did Usha get? So always marks are of numeric type, right? So data mining is numeric. Next, web technologies, all the marks are represented in numeric format, and even total is also in numeric. And coming to the result will be pass or fail. So this is your class label or your class variable. And once after specifying all the attributes, next you have to give the data. That is, you have to give the rows in your data set. Always the data has to be separated by comma. So this is how you will write an ARFF file and save it with the relation name .arff. So in your question, the first thing they have asked is create an ARFF file and read it into Weka. We have read it into Weka and explore the purpose of each button under the preprocessor panel. Actually, see, this particular panel is nothing but preprocessor panel. Here you have an underline, right? If you click on classify, it means that you are under the classify panel. Under the preprocessor panel, first we have already seen open file. So with this particular button, we can open a data file. It can be an ARFF file, it can be a CSV file, any types of files we can open. We can also load the dataset using OpenURL, OpenDB, or also generate. And next you have a edit option and a save option. So once, let us see what will happen if we click on the edit option. So when I click on the edit option, here I can see the entire data set with the values assigned. So these are the student SIDs, student names and marks in each and every subject, and finally is the class label which will specify pass or fail. So here you have only 6 rows. If you want to enter more rows, you can simply click here add instances, and when you click add instances, uh, the numeric values will be assigned as 0, and you can click on them and change the value to some value. So I have given 50 and it will be saved. So like that you can perform any changes and click on OK, and the change will be done. And save, you can save whatever you have done till now, and when you click on save, you can save it. If you want to overwrite, yes. And next, if you see here current relation, it specifies the relation name, number of attributes, number of instances. And here attributes, you can select all the attributes, you can select none of the attributes, you can invert, and you can check the pattern also, and this is not much use. And here you will be finding all the attributes and their class labels. Here the selected attribute, whatever selected attribute is there, suppose DM, it specifies the type, it specifies if there are any missing values, how many distinct values are there, and it will give you the minimum value, maximum value, mean and standard deviation, and this will specify the visualization of your attributes. So that is the first part, and the second part we have finished. Also try to interpret using a different ARFF file, weather.arff provided in Weka. So up till now, what we have done is we have created our own data set and we have loaded into the Weka module. But suppose another way is, already there are some pre-existing data sets and those data sets are available in Weka itself. So you can open those data sets also and do any type of classification or clustering or association. So how to open them? So go and click on open file, and then you have to go to your um, C drive, program files. Under program files you have Weka, and under Weka you have data, and these are the pre-available data sets in Weka. So you can use these data sets to perform any type of data mining tasks. So here they have asked to use the weather.arff. So here I am using weather.nominal. Now what is meant by nominal? Nominal is nothing but it is simple and easy to distinguish. That is, you can check whether equal or not, or it can be in simple English text. So after here, if you can see weather dot symbolic relation. So weather dataset has been loaded. The number of attributes are 5. Here if you can count, there are 5. Number of instances are 14. And if you click on Outlook, its corresponding details are listed over here. It is telling that the nominal values, that is simple English words, will be there. So what are the nominal values? Either sunny, overcast or rainy. And how many sunny are there? 5. 4 number of overcast are there and 5 number of rainy. So total it will be giving you 14. So 14 instances, so 14 rows. And if you click on temperature, here also it will be giving you the labels are the temperature will be taking values hot, mild, cold. And this, if you click on edit, basically edit is used to add some more things into the table, or you can change any of the values already that are being there. So here if you can see, all the data in this data set are in the form of texts. So it is called as a nominal data set. So this is the end of the first module.